I'll ask first, is anybody squeamish? Okay, so there's not a lot of stuff here then. So I put the happy little blood cell there to try to kind of set the palate so I don't have any real gross pictures. And, you know, in talking to Butch and trying to figure out how I was going to do this, I took a couple of different approaches. So this is quasi-scientific, hopefully not too much, and you won't get too bored. Quasi-historical, and then hopefully more spiritual than anything. And, you know, if he'd asked me to give a talk on the divine design of the stomach or the colon or the small intestine, I'd be much more comfortable. But you know, I have some experience with blood too. So I'm a gastroenterologist, but I started out, doing regular medical school and doing medicine, an internal medicine residency. I was an internist for a couple years before I did my fellowship in GI. So I learned all this stuff at one point in time, and it was great to relearn a lot of it, although I hadn't really forgotten much of it. But it is amazing as I researched this and tried to prepare this. So it's okay if you don't suck me. Suck it in. Just the true divinity of the design of our bodies. We take this first just so granted. You know, when we get a little cut on our finger, I don't really think about it. A little blood, put a little tissue on it, squeeze it, it stops. Blood is an amazing thing, and so it's going to be. So I'm going to start this off. I actually didn't prepare this slide. Does anybody know what the most common word in the Bible is?
Thou.
No. So aside from thee and a and of, and so the most common.
Blood.
No, not blood. Lord is actually the most common. God is number 2. Blood is in the top 100. Anybody? I'm not going to ask a guess. It's like a jelly bean question. How many jelly beans are in the jar? Blood's mentioned somewhere between about 430 to 450 times in the Bible. About 330, depending on the source that you use in the Bible that you're looking at. About 330, 350 verses have the word blood in it. So it really is a miracle. You know, and I'm going to set this up with a kind of an analogy. We think about our cars or other machines. They need oil, they need transmission fluid, they need brake fluid, antifreeze, steering fluid to make the whole thing work and together and do what we want it to do. Now, if you can imagine a single multi-purpose fluid for our cars or our machines. This fluid is circulated from a central reservoir. Each part uses only the needed properties of that fluid. Each part of the machine just takes what it needs from that particular fluid. It might be all of it, it might be just a part of it. It's self-regulating. It excludes detrimental or obsolete properties of that fluid. It self-cleanses and is constantly recycling. Well, that's blood. That's exactly what blood fits those properties. It's a brilliant integration by God of those fluid properties for the diverse needs of our physical bodies. And it begins about 15 days after conception in terms of the formation of the fetus and the baby of blood and blood vessels. So in the ancient world, blood was a sign of health and life. You know, the life of a person's body was in the blood. And when a person died, blood was spilled. The loss of life or loss of blood is an indicator of non-life. That's from Isaiah. And there's some other verses there. When we think about how ancient man looked at blood, there was something called the 4 humors. I'm sure you all have heard about this. This was really perpetuated and it was originated with Pagans. Hippocrates taught this, and then Galen was really given a lot of credit for promoting this concept. He was a student of Hippocrates. He was born in 129 AD. He was a surgeon, a physician, philosopher. And he really perpetuated this 4 humors theory. And the 4 humors were blood, black bile, yellow bile, and phlegm. I'm not sure what black bile and yellow bile are. I know what phlegm and blood are. But the thought was that when these humors were balanced, that health was ensured. So a loss or an excess of any of these humors produced physical, mental illness, and disability. And that was one of the things that led to the practice in ancient medicine of bleeding people. When they had fevers or when they appeared sick, they would take some of these humors out, most often with blood. Galen thought these humors were influenced by dietary and activity levels, so he promoted the importance of a proper diet and exercise That's great, batting 1,000, but he also prescribed drinking dog or weasel blood to cure rabies. So I'd say he's batting about 500 in terms of those medical recommendations. So number 1's good, number 2, not so great. I lost my, there we go. Okay, so blood formation, first human cell after fertilization divides rapidly, and it becomes a small cluster. That cluster implants in the uterus. It flattens out to a disc. We're not going to go into all that terminology. It's only a few cells thick at that point, and it gets the blood and the nourishment from the mother through just diffusion of those nutrients across cell walls. But by 2 weeks after fertilization, that disc that's implanted in the uterus, the fetus, becomes too thick for that diffusion, so it outstrips the embryo's need for a nutrient system. So that's when blood and blood vessels start to form. So 2 weeks after conception, we start to see blood and blood vessels starting to form. Within 3 weeks after conception, the heart starts to form. Now at that point, it's something called a heart tube, but that is the precursor to the heart. And the cardiovascular system that carries the blood and makes the blood is the first organ system that actually becomes functional. There's a picture of the, I don't know if this is going to, I didn't mean to do that. Let's see if I can get my laser pointer. So that's the blood, or the heart tube right there, 21 days. You can see even after 2 weeks, we start to see early blood vessel formation. And at that point, the blood cells are actually being produced within those tiny little blood vessels. So the embryo makes red blood cells, and that's, I'm going to call those RBCs. I'll kind of flip in and out, and just to save on space, I started abbreviating. That's what we typically do in medical lectures. First, in a temporary structure called the yolk sac. Now, it's a very misleading term because there's actually no such thing as yolk in a human body or in a fetus or an embryo. It contains a yellow substance, so it was called a yolk sac, but it really should be called a blood-forming sac. These progenitor or early red blood cells migrate from the yolk sac to the liver and the spleen, and those actually take over blood formation in about 2.5 months gestation. By the 5th month, the bone marrow takes over, and that is the site of blood production in all of us for the rest of our lives. In adulthood, the spleen and the liver can start making blood in extreme circumstances. So when somebody's septic, they're in the hospital, they're critically ill, the spleen and the liver can actually start making some blood as emergency backup sites. In children, the long bones like the legs and the shins are the site of major blood production, but in adults it's mostly the pelvis, cranium, the vertebrae, and the sternum, your chest. And then development and activation and proliferation of specific types of cells, especially white blood cells, occur in other organs such as the spleen, thymus gland, and lymph nodes. And we'll talk a little bit more about the different types of cells in the blood as we move forward. And there's this incredible control mechanism that God created that maintains that balance of production and loss. We're always losing blood. We're always bleeding. We bleed internally, but God has designed it so it stops almost instantaneously. All of us are bleeding in some very, very small form somewhere in our bodies, usually the GI tract, but the miracle of what God has designed is an immediate cessation of that bleeding. Control mechanisms maintain that balance about 1,200,000 cells per second, lost and formed. So you kind of think about the scope of some of these numbers that I'm going to share with you. I'm going to talk a little bit about the bone marrow. This is a protected microenvironment where immature cells, stem cells, live in a meshwork of fat cells. They get nutrients from those fat cells, large white blood cells called macrophages, and other cells lining the marrow. This network or meshwork compartmentalizes the blood formation process and also elucidates what's called colony-stimulating factors, or CSFs, and this directs what types of cells are made, how many cells are made, and there's about 12 different colony-stimulating factors that are introduced. I'll talk about the most important one in a second. But again, another example of divine design. So in terms of concentration, what the bone marrow in the body can sense to stimulate that blood formation. So it can be as low as 10 to 12 molars in terms of concentration of colony-stimulating factors. That's, to put that in real terms, that's like a grain of salt dissolved in 27,000 gallons of water. And the body can sense that concentration and say, okay, I need to make more red blood cells, I need to make more white blood cells of a certain type. So that degree of sensitivity. Some cells actually secrete their own colony-stimulating factors, so it becomes a self-regulating type of process as well. All right, so our blood comes from what are called stem cells, both red blood cells as well as white blood cells, as well as other types of tissues. But primarily, we're just talking about blood right now. Platelets are another type of cell. It's almost like a cell fragment, and those are the three major types of cells in the blood. Red blood cells, white blood cells, and platelets. Red blood cells by far the most numerous. I'm not going to go into a lot of this detail, but just the point that, you know, the production and destruction of blood is controlled by these chemicals, these colony-stimulating factors, and that is monitoring basically the health of the body and telling the bone marrow to slow down or pick up if needed. And it's really a really remarkable pathway that through which blood is formed. So the most important colony-stimulating factor is erythropoietin. Many of you probably are familiar with erythropoietin, especially in the bicycle racing community, and Lance Armstrong. These racers would take erythropoietin to make more red blood cells because that would increase their oxygen carrying capacity. That's what red blood cells do. That's their sole purpose, is to carry oxygen to the rest of our body. So erythropoietin is the most crucial CSF, a colony-stimulating factor for red blood cells. The term of red blood cell formation is, the fancy term is erythropoiesis. So that's where this comes from. Now, this is a steadily circulated colony-stimulating factor. The genes responsible for how much erythropoietin is being made are primarily controlled by the amount of oxygen that they sense, the body is sensing. And erythropoietin actually comes from the kidneys. So we got bone marrow, we've got, we've got the spleen, we've got the liver, we've got the kidneys involved. The entire body is involved in blood formation. We've got a controlled loss and production of blood based on things that are going on in the body in terms of that balance. So erythropoietin is made in the kidneys, and it tells the bone marrow and the progenitor cells to make more red blood cells or to slow down, and it just maintains, in health, it maintains this perfect balance. So vital characteristics of blood: it's a liquid tissue, this liquid property, and it really is a tissue. It's got, just like we call skin a tissue. We don't think of it as an organ, but skin is an organ. Blood is also an organ. This liquid property, it's the only liquid organ that we have in our body. It's crucial to allow it to do its function. It is perfectly designed by God. It carries suspended or dissolved solids and gases. It responds to even those slight pressure changes. I mentioned that concentration of some of these colony-stimulating factors. And it also can continuously change shape. I'm going to show some pictures here in a second. It should not make you squeamish, I hope. Blood and blood vessels, and we don't want to leave blood vessels out. This is the highway for blood. Those blood vessels form an incredibly flexible conduit. If I move my arm, my blood vessels are changing shape and moving. They contour to our body's position at any point in time, and it connects the outside world to the deepest cells in our body. And we'll talk about how many cells are in the body. 60 trillion cells are in the body, on average. Some of us have a few more cells, and perhaps we'd like a few less cells. Some of them are a little bigger and more expanded. Marianne and I were talking about this as we were driving in terms of salads for dinner coming up. So certain metabolic, our cellular metabolic demands of these 60 trillion cells are relentless. They are like the feed me Seymour, ant plant. They always want oxygen. They need nutrients continuously. Each one of these cells, each one of these 60 trillion cells is carrying out, on average, 10 million chemical reactions per second. So it just really these numbers kind of boggle the mind in terms of the incredible complexity with which we were actually created, and the miracle that we can actually live and be alive and flourish in our human bodies. The blood has to be in close proximity to the blood vessels. The blood vessels have to be in close proximity to all of these cells to provide them the nutrients, the oxygen and the fuel that they need, the carbohydrates and the sugars and the energy that they need to actually function appropriately. So not a bad cartoon here, showing some of the different types of blood cells. You've got white blood cells here. These are called granulocytes. The red blood cells are here. We'll take a closer look. There's a little platelet right there. The red blood cells by far outstrip the amount of other cells in the blood. Now, in the time it takes me to read this sentence, your body is going to produce 17 million blood cells in your bone marrow. 17 million. Now it's 34, we can just keep going on and on. That's twice as many cells, those cells is twice as much as the population of New York City. And once created, these are moving into the bloodstream, and we've got 60,000 miles of blood vessels in our bodies on average. So now this is getting down to the very, very microscopic blood cells, the capillaries, or blood vessels, the capillaries. But if you laid it out end to end, it would add up to about 60,000 miles. Now, we'll talk about blood components. It's got solid forms, those are the cells, red blood cells, white blood cells, platelets. The white blood cells are disease-fighting cells. The red blood cells are oxygen-carrying cells. And the platelets are clotting cells. Most blood is water, 92% water, only 8% solids, and there's gases and other things that are dissolved in the blood. Mostly oxygen, but also carbon dioxide, especially as these red blood cells drop off the oxygen, they pick up the carbon dioxide, they all come back to the lungs, we breathe out the carbon dioxide, we take in the oxygen. Oxygen is 21% of the atmosphere. Anybody know what most of the atmosphere is made of? Which gas? Nitrogen, exactly. Fair amount of carbon dioxide, perhaps increasing. That's a lecture for another day. Glucose, that's the sugar that the cells need. That's the main sugar that cells use. Most carbohydrates or sugars get broken down into glucose. That's the simplest form of sugar. Albumin, which is a protein that it has oncotic pressure, helps maintain our blood pressure, but it also carries a lot of other things. Hormones, as well as antibodies. And our body has sensors that continually monitor the concentrations of these components and makes instantaneous adjustments in terms of maintaining that balance in the blood. Now, vital body functions like maintaining a normal acid-base ratio, intracellular water content or blood pressure, basically, the blood's ability to flow through vessels and maintain and manage body heat production are all depend on that proper mix of blood components. All right, this might make you a little squeamish. Close your eyes, but just there, I'm just going to talk about some of the more sacred aspects of this, but we're going to still talk a little bit more science, but we're going to get to the end of science and talk a little bit about history here in a second. Blood components, again, I've already mentioned most of it is water, 92% water. 3 primary cell types, we've gone over those, but just to reiterate what those do and kind of show you what they look like in cartoon form. So, in the time it took for us to look at that last slide, all the blood in your body completed its journey, and it's got back to where it started from, and then it did again. So it travels from your heart to all of your extremities, and then continues that process. That heart is that central origin. The blood vessels are a complex roadway. We already mentioned 60,000 miles of blood vessels carry the blood to the rest of the body. And it's also accompanied, those arteries are accompanied by veins. So where you have an artery, you have a vein. And the vein is what returns the blood to its journey. So the arteries send out oxygen-rich blood from the lungs. The veins carry oxygen-poor, carbon dioxide-rich blood back to the lungs. But also, as they go back to the lungs, they go through the spleen, and they go through the liver, and that cleanses our blood. That's some of the main processes of the spleen and the liver, is to cleanse and detoxify our blood from viruses and bacteria and other byproducts of metabolism. So just another kind of cartoon showing the red blood cells and the white blood cells all traveling along. There's a picture of the blood vessels. These are the major blood vessels. So this is not 60,000 miles of blood vessels, but you've got your iliac arteries here going down to your femoral arteries, your aorta, some of your subclavian. I won't go through all of them, but these go up to the brain, these go out to the extremities. This is the big, we call that big red. That's the aorta. We don't like for that to be threatened. The things that I end up dealing with in gastroenterology are some of the blood vessels that come off of the aorta and feed the gut. So There's about 3 of them that we deal with. So we'll talk a little bit about the red blood cell. This is an amazing cell. I mean, it's such a simple cell. It looks like a Cheerio, but the design of the cell is perfect. This is what we call a biconcave disc. If I showed you the flip side, you'd see another indentation. This looks like a frisbee with the center not cut out, or a bagel that's been stomped on in the center. And that is a perfect design that God created. This biconcave shape bestows the highest possible surface area to carry oxygen. And these cells carry oxygen with a protein called hemoglobin. And hemoglobin is the primary thing that carries oxygen, drops off oxygen. There's more than 250 million hemoglobin molecules per cell. We already talked about the billions of red blood cells that are floating around. Each one of those little cells carries more than 250 million hemoglobin molecules, and each hemoglobin molecule carries a couple of oxygen molecules. And they onload and offload instantaneously in a fraction of a second. The majority of those blood vessels that we talked about, the 60,000 miles, are actually capillaries. You can't see capillaries with the naked eye. They're microscopic. You'd have to even see them, you have to put 40 of them alongside each other to hit the diameter of a human hair. The red blood cells are twice the diameter of a capillary. So that doesn't quite fit. How does that big cell get into that tiny little blood vessel? Well, God created it so that those red blood cells can deform and squeeze and contract, and they're flexible. And so they're able to squeeze through those capillaries, do what they need to do in terms of dropping off oxygen and other nutrients, and then pick up the toxins and carbon dioxide. There's 5 specialized structural proteins that allow that. When one of those proteins is broken, you get fragile red blood cells that can rupture or get stuck and cause clots. An example of that would be sickle cell disease, and there's several others, but those are diseases of the hemoglobin molecule as well as some of the proteins that are associated with red blood cells. So this is what a capillary bed looks like. This is where the important stuff really, it's all important, but this is where the rubber meets the road. The oxygenated blood comes through smaller and smaller arteries. These are called arterioles. There's tiny little muscles that control the flow, depending on epinephrine and adrenaline and oxygen status and other messages. And the blood will enter this capillary bed. This is a fine meshwork of really just one cell thick blood vessels. They diffuse and oxygen is dropped off, carbon dioxide is picked up, and then the blood returns through the venous system. And then you get bigger and bigger veins until you get to the inferior and superior vena cava. Those go back to the lungs and the heart, and then the whole process repeats itself. So red blood cells are living tissue. It's impossible for red blood cells to consume their oxygen. So they're living. Everything that lives uses oxygen, except for red blood cells. Red blood cells have been designed by God to not use oxygen. They're anaerobic. So they don't use up the oxygen that they're carrying in their hemoglobin. They leave that for the rest of the cells of the body. And there's some other, I thought this was fascinating, and I knew this, but I had forgotten it, but there's other types of cells that you can imagine. If we had blood coming through our eyes, in its state that we always think about it, we wouldn't be able to see, or everything would be red, right? So God has designed our bodies. There's several organs with these incredibly fine mesh or filters, basically, that keep the solid red blood cells out, but they still allow oxygen and the other nutrients to diffuse across. The eyes would be an example of that. The kidneys would be an example of that. That's why most of us, hopefully, don't pee a lot of blood or see blood in our urine. If you do, that's a bad thing. You should go see a doctor about that, not a gastroenterologist. But there's other areas of blood that do that. Cerebrospinal fluid is another one of those types of areas. So fascinating design there. We'll talk a little bit about white blood cells. I promise I'm going to get to some spiritual stuff here in a second. But the white blood cells, similar to the red blood cells, start out as a stem cell, and then they differentiate into their particular type of function. Now, and I won't go through all this, but just realize there's something called granulocytes. Granulocytes are these types of cells. They have granules in them. That's why they're called granulocytes. These work with regards to their main function is is defense against viruses, against bacteria, against foreign agents. They are also the cells that mediate allergies or allergic reactions. Monocytes don't have granules in them. They're mostly made up of a nucleus. These are antibody-producing cells, and that nucleus is the main thing that does that. So that's sort of lymphocytes. So if somebody has lymphoma or leukemia, that is usually leukemia is a disease of all the white blood cells, and there's certain types of leukemia. Lymphoma is a disease where you have unregulated production of lymphocytes, and they're dysfunctional lymphocytes, and makes people prone to infection and multiple other complications. So white blood cell function primarily to protect us. We're always getting exposed. Our food is not sterile. We're exposed to each other. I think COVID certainly brought this home, of course, right? And just general infections bring this home. Neutrophils is the first responder of immune cells. There's something called basophils. They're called basophils because they're blue under the microscope with some of the stains. So it's a basophil. That in medicine, basophilic means bluish. And these cells have a lot of histamine in them, as do eosinophils. There's a condition in gastroenterology that we deal with called eosinophilic esophagitis, and it's an infiltration of eosinophils in the esophagus, and people feel like food gets stuck. Lymphocytes, as I mentioned, are these B and T cells. They make antibodies to fight specific invaders. Antibodies are specifically coded to fight against specific invaders or viruses or foreign allergens. And then monocytes, they're another type of white blood cell, and they're basically the Swiffer. They come back, they go through and clean up dead cells. It can be dead blood cells, but other dead cells in the body, or senescent cells. So just a microscopic picture here, a lot of red blood cells here. You can see how small they are. These are all white blood cells, and they're much bigger, and they're typically bluish. They've got large nuclei, and those nuclei are telling the cell to make things like antibodies. And here's a picture of a white blood cell eating or destroying a bacteria. The bacteria is this orange thing, and the white blood cell is coming in and basically engulfing it. That's called phagocytosis. Phagio means to eat, so if somebody has difficulty swallowing, they have dysphagia. That's the phagocytosis process. And the white blood cells have their own circulatory system. This is called the lymph system. Lymph nodes are part of the lymph system. But just like the capillary bed and the arterioles and venules, you also have a closely integrated lymphocytic or lymphatic bed system that does essentially the same thing. It delivers these white blood cells to those tissues. Only one slide on platelets. Platelets are important cells. They're kind of the big dumb cells. They basically just cause clot. And so when we bleed, even microscopically, and that's where most of our bleeding occurs, and it's always happening, these cells cause an instantaneous clot. Sometimes it can be a bad thing, and these cells can cause a clot in an artery of the heart. That's a heart attack. It can cause a clot in an artery of a brain. That's a stroke. In the GI tract, these cells may not work. We take lots of patients on what we call anticoagulants. That inhibits these cells. And when some patients do develop ulcers, they don't clot, and then that's when I get to go in at 2 in the morning and see them. All right, so anybody know what this picture is of this building? Huh? Not the Vatican, but it is in that country. Well, actually, it's not in that country. So, my wife and I are going to go here in November. This is the Duomo in Florence, and if you see the people, there's people up there. I've been here. I went with Grayson for his high school trip. So this is Florence. And there is a stairway that's basically, it's kind of like that capillary bed. I should have put a picture of the stairway because it's exactly like that capillary bed. It gets narrower and narrower and narrow, and so you have people coming down, you have people coming up, and there's only room, especially when I'm going up, room for one person. And for Marianne, probably two. But we're going to see if we can get Marianne up here, who has developed since I've been married to her for 33 years, the girl I met would go on every roller coaster, and now she's scared to go up the stairs. So we're going to see if we can get her up here. But I'm going to talk a little bit about history, just a little bit. Now, I'm going to preface this by these three discoverers. I'm not going to call them scientists because they weren't really scientists, but amazing Christians true believers. And the point that I kind of took from this is you can have a strong, strong faith and be completely devoted to God and still be steeped in the sciences. I think scientists and sometimes get a bad rap as being agnostic or perhaps even atheistic, and I don't think that's entirely true. It certainly wasn't in these times. Now, this is hundreds and hundreds of years ago, but Sir William Harvey got a lot of credit for being the first to quote-unquote discover the concept of circulation of blood through the heart, the arteries, into the veins. He realized that biological life is maintained by the blood, bringing nourishment to the parts of the body. What he couldn't figure out was how the arteries and veins were connected, or even if they were connected. Now, he got credit for this in 1628, but actually about 400 years earlier, somebody named Ibn al-Nafis described blood flow through pulmonary circulation and coronary arteries as well. And in 1559, Colombo actually described cardiac contraction. So while he got credit for it, there were other folks who had noticed this. This is perhaps the most important of the discoverers in terms of blood and blood properties, at least early on. Anton van Leeuwenhoek, 1632 to 1723. He was a draper. He was not a scientist. He was a Dutch draper. And he wanted to see what the quality of his thread was like. But he was frustrated with the magnifying lenses that they had available at that time. So he took it upon himself to develop an interest in lens making. He's basically the father of the microscope and the modern lenses of the microscope. He took soda lime glass, he would draw it out in these very thin whiskers, and then he would melt one end of that to make a high quality, a very small high quality lens, and he basically refined the microscope. Now, a microscope was being developed in the 1600s, and at that time it was a new thing, and a lot of people, kind of like when cameras were coming out, people were getting very interested in this technology and looking at these smaller and smaller things. He is actually the first to describe red blood cells, as well as other cellular blood components, and he produced a detailed account, and even in 1719, he came up with a measurement of a red blood cell of 0.003 inches, that's about 6 to 8 microns, average 7 microns. And that's actually a very accurate measurement for a red blood cell. So, brilliant person. I don't know how he did that, but just incredibly brilliant. He's also the first to document things like muscle fibers and bacteria and crystals and gout, along with a lot of other things. Joseph Jackson Lister, he lived in the late 1700s, the mid 1800s. He was a wine merchant. And ironically enough, was a Quaker. Kind of controversial there, maybe. But he was deeply interested in natural history. He realized that the microscopes available in the early 19th century didn't provide adequate resolution, so he developed stands for microscopes to set them still, but he also spent a lot of time trying to improve objective lenses, and so he really revolutionized the whole concept of double objective lenses and microscopes and made those images even better. He did all this in his spare time while he was fully engaged in his wine business, but he was the first to describe what rouleau formation, which I actually took that picture out, but it's basically the lining up of the little red blood cells in the capillary beds. It's almost like a subway car, if you will. And he also helped describe Hodgkin's disease with Dr. Hodgkin. And then he was the father of Joseph Lister, who was the pioneer of antiseptic surgery, for whom Listerine is actually named. Now, Listerine was developed by a St. Louis physician named Joseph Lawrence, named it after Joseph Lister, not Joseph Jackson Lister, but the son, Joseph Lister. And it was originally a surgical antiseptic. So if any of you use Listerine, then you can feel comfortable knowing that you're swallowing a surgical antiseptic or putting that in your mouth. So, all right, let's talk about the power of blood in Jesus Christ. So we'll get a little bit more spiritual and a little bit more relevant in terms of why we're talking about this. So, blood is sacred blood. So first and foremost, while Jesus had a human body, what flowed through his veins was sacred blood. And he was born of a virgin. The blood type is determined by the father's lineage. So if Jesus is the Son of God, which he is, it was God's blood that was flowing through his veins. Acts 20:28 says, "Keep watch over yourselves and all the flock of which the Holy Spirit has made you overseers." Be shepherds of the church of God, which he bought with his own blood. Jesus' blood is God's blood. It is sacred blood. All right. It's atoning blood. So it's sacred blood. It's also atoning blood. Mosaic law said that blood, when shed on the altar, served as an atonement for the soul of the guilty sinner, making the offering. The life of the flesh is actually also its soul. The word for life and soul both translate into the same Hebrew word. That's the word nephesh. The life and soul are the same. When blood was offered as a sacrifice, it was thus being offered as it was a life offering. It's a substitution for the life of the sinner who deserved to die for their sin. This is under Mosaic law, so I want to make that clear. Now, in Judaism, couldn't do human sacrifices, thank goodness. They were prohibited. Oops, I just turned off the microphone, sorry. Probably better. See if I can do that. I'm fiddling with my hands in my pocket. All right. See if I can turn that back off. Yes, it is. Okay. No man could die for another man because man was inherently sinful. So if man would sacrifice themselves for somebody else's sin, it still wouldn't be a clean offering. So they had to use the blood of a clean animal. Animals don't possess the image of God, including the ability to reason right and wrong, therefore cannot sin. It certainly can't reason between right and wrong. Anybody who's met Moose can attest to that. That's our dog. So animals were used as a substitution, but even such clean blood of an animal could only serve as a temporary covering, and it couldn't completely take away sin. So in Judaism, the shedding of blood, and that's an important word as opposed to the spilling of blood, was designed for purification and dedication of the tabernacle and forgiveness of an intentional sin. But that was extended and misused by man, and Jesus actually came to redeem that sin of misusing the law in terms of that atonement. It's shed blood. So, and I mentioned that difference between spilling blood and shed blood. Shed blood is given voluntarily. It is a voluntary act. Hebrews 9:22 says, in fact, the law requires that nearly everything be cleansed with blood, and without the shedding of blood, there is no forgiveness. It was not spilled blood. Spilled blood is blood lost in battle, blood lost as a result of an accident, let's say. And this contrasts the sacrificial system of the Mosaic law, which was spilled blood of an animal, with what Jesus accomplished through his death on the cross. John 10:18 says, no one takes it from me, but I lay it down on my own accord. I have authority to lay it down and authority to take it back up again. This command I received from my Father. Jesus did not die as a martyr with spilled blood. He actually was a willing substitute with his shed blood. So it's atoning blood, it's shed blood, it's sacred blood. It's also, more on this, Jesus is the permanent solution to the sin problem through that shed blood. John 1:29, the sinless Lamb of God, which taketh away the sin of the world. Neither by the blood of goats and calves, but by his own blood he entered into this holy place, having obtained eternal redemption for us. And since his life was in his blood, this is Colossians 1:20, he has made peace through the blood of his cross. All right, it's also saving blood. So atonement, sacred, shed, saving blood. We're saved by the blood of the Lamb, according to Leviticus 17:11. For the life of a creature is in the blood, and I have given it to you to make atonement for yourselves on the altar, and it is the blood that makes atonement for one's life. 1 Peter 1:18-19. For you know that it was not with perishable things such as silver or gold that you were redeemed from the empty way of life handed down to you from your ancestors, but with the precious blood of Christ, a lamb without blemish or defect. And then finally, 1 Corinthians 15:22. For as in Adam all die, so in Christ all will be made alive. Jesus Christ came as he did. He was virgin born, blood of God circulating through his vascular system, in his bone marrow, to be what he was, sinless, and to do what he had to do, which was to die as our substitute. By the virgin birth of Christ, he became man that we might become sons and daughters of God as well. I'm going to segue a little bit and talk about saving blood and blood transfusions. This is some just interesting history, I thought. 1628, this person named Johannes Halle hypothesized that blood transfusions might actually prolong life. And in 1639, 11 years later, Francis Potter, who was a vicar, actually apparently created a series of feather quills and tubes, and he transfused chickens with blood. Don't know why, but he did. And it was he postulated this would cure disease. He may have been the first person to ever transfuse blood in animals. He was also better known, though, as the author of a tract that identified 666 as the number of the beast, another weird little trivia thing. So Francis Potter was doing a lot. In terms of transfusions, first human-to-human transfusion was in 1818. And we think of this as being a relatively modern thing. This is 50 years before the Civil War. This is done by James Blundell. He was a physician, obstetrician, and physiologist, and he was trying to treat a man with gastric cancer. Unfortunately, it didn't turn out so well because it's not a cure for gastric cancer, of course. Anybody ever heard of Braxton Hicks contractions? Braxton Hicks was the obstetricians were really involved in these blood transfusions. So Braxton Hicks was an obstetrician, and he was the namesake of Braxton Hicks contractions. He promoted the use of chemical substances. The problem with blood, of course, is it's got platelets in it, right? So if you take it and put it in a bag, it's going to clot up and it's going to be unusable. So he promoted the use of chemical substances to produce some anticoagulant effect and hopefully improve the success of blood transfusions. The other issue with giving blood transfusions without anticoagulants in them is that as you infuse them into somebody else, they start clotting, and that's a bad thing. You can lose limbs, and the main issue with blood transfusions these days is actually allergic reactions and incompatibility reactions. In 1869, he published a report of using the use of phosphate of soda as an anticoagulant, and sodium citrate was introduced in 1918 by James Graham, and that's one of the ways that we now store donated blood for prolonged periods of time. It also has to be refrigerated. 30 million blood components are transfused annually in the U.S., and it is very well tested. If anybody ever needs a blood transfusion, as I mentioned, the major risk of a blood transfusion, and I say this to every single patient I end up doing an endoscopy on because we have to get consent forms for blood transfusions. The major risk is actually not infectious diseases, but allergic reactions due to incompatibility. Infection used to be a really big deal. This was one of the main ways that hepatitis C and hepatitis B was passed, as well as other infections in terms of risks, but those are screened very carefully. So now we'll get back to some spiritual stuff. It's shared blood. All right, so John 6:53 says Jesus actually speaks about eating his flesh and drinking his blood, but he's doing that symbolically to make those that he was speaking to alive, and that's what he was trying to convey. He was saying, let my life be in you through drinking my blood and eating my flesh. Jesus is to your spirit what blood is to your body. Just as the life of the flesh is the blood, the life of your spirit is Jesus Christ. He's talking about his life being alive in us. And I think many Christians aren't living in victory because they've never understood the concept of sharing blood with Jesus. You know, we have his blood floating and circulating through us as well, just by believing and having faith in him and the Lord. It is cleansing blood. We've talked about the liver and the spleen and the self-regulating. Red blood cells not only supply every cell with oxygen, they carry away toxins. We already talked about that. In 1 John 1:7, talks about the blood of Jesus constantly cleansing. If we walk in the light, as he is in the light, we have fellowship with one another, and the blood of Jesus, his Son, purifies us from all sin. And this is not past tense. You know, I other than the underlining of purifies, I copied this exactly as it's written. It's present tense. His blood is continually cleansing us. If we're cut off from his blood, toxins will build up within us, spiritual toxins, emotional toxins, excruciating pain, worry, fear, we can go on and on and on. This is why we need his blood to cleanse us and why it is such a miracle. And I think the thing I got away from in terms of preparing this lecture is the miracle of the physiology of blood formation and the function of blood and the blood vessels. That's even trumped and expanded upon millionfold or exponentially by the miracle of blood in our lives and the blood of Jesus Christ in us and the blood of God in us. So let's move on. So just as in our physical bodies where everything we need to exist is delivered through the blood, everything we need as Christians in Christian life is found in blood. It's sacred, it's atoning, it's shed willingly, it's shared, and it's cleansing. And those are the themes of this last part. And I think this is not just a metaphor for his purification and his rescue of us. Under the Mosaic covenant, among the Jews, blood was used to inaugurate the covenant, indicate to the people that they've been set free from slavery. But with Jesus in the new covenant with God, this is to the entire world. And blood and its purification was meant to indicate to all people that we no longer are slaves to sin. And that's the new covenant of God with the shed blood of Jesus Christ. So, just to conclude, really decent on time, I guess. Hopefully I didn't get too much into the science, but the numbers are so incredible, and the way that the body and God designed us is just, you think about, and there's so many other examples in the way our bodies work too. And we can have a dissertation about colonic function later if you want to, but I'll turn the microphone off. But, this is, it's such a 450 mentions in the Bible, 350 verses, one of the top 100 words in the Bible. Blood is essential to the biblical teachings that God has given us. It's central to our faith. It's central to Jesus' death on the cross. So just to conclude, from the earliest days in the mother's womb until the day of death, a person's life is in the blood. A person-to-person gift, such as the transfusions, called the gift of life. And I wanted to draw that direct analogy to Jesus Christ and the transfusion that we have received through Jesus Christ. He gave his blood transfusion to us so that in so doing, he gives us a meaningful life on earth, hopefully, but even more valuable and everlasting life with him in his presence in heaven. And so that's really the takeaway that I got from this is his blood is precious because it's able to redeem and cleanse us from all sin. And then finally, Revelation 1:5, let us give glory unto him that loved us and washed us from our sins in his own blood. So with that, I'll stop.